Welcome to The Explainer. Look, if you're an engineering manager or a tech lead right now, you already know things are getting pretty wild out there. Your day-to-day job today probably looks absolutely nothing like what you thought it would, even just a couple of years ago. We are all currently navigating this incredibly rapid and, frankly, kinda confusing transition right into AI-driven software development. The hype is literally everywhere, and the pressure on you to move faster is intense. But here's the real question. How do we actually do that without just breaking every single thing we've built? Well, today we're going to break down this concept of software ecology to help you safely manage this massive shift.
So here's our operational playbook for today. First, we'll hit the AI productivity trap. Then, we'll enter software ecology. Third, we've got the system bottleneck checklist. Fourth, culture and sustainable teams. And finally, number 5, managing the forest. We're going to move past the flashy allure of sheer speed and get into some really practical long-term strategy.
All right, starting with section 1, the AI productivity trap and the illusion of speed. We really need to pause and explicitly challenge the hype around these AI code generation tools. Right now, the whole industry is obsessed with making the code machine go fast, right? We're measuring productivity by the sheer volume of code hitting the repo. But raw speed can actually be an incredible trap if your underlying systems just aren't prepared for it. Imagine waking up tomorrow and your team is suddenly experiencing a 10x explosion in code volume. What actually happens? We throw around 10x productivity like it's the holy grail, but if everyone on your team suddenly has AI agents churning out 10 times more commits, you really have to stop and deeply consider the cascading consequences that's going to have on your current systems. It reminds me of that famous Jeff Atwood quote, "Software is a liability." It's so true, but it's something we all conveniently forget when someone hands us a shiny new tool that lets us write code infinitely faster. Let's be real. 10 times more code immediately means 10 times more organizational liability. It's 10 times more maintenance debt, 10 times more surface area for bugs. And crucially, it's 10 times more logic that a human being eventually is going to have to read, understand, and secure. Because there is a massive distinction we have to make here. Generating code 10 times faster, that's just programming. But engineering 10 times faster, that is something completely different. As the source material points out, engineering is basically programming integrated over time. These AI agents, they are fantastic at writing isolated blocks of code, but they don't necessarily think about long-term maintainability. They aren't grappling with complex system architecture the way a seasoned human engineer has to. Which brings us nicely to section 2. Enter software ecology and the systems view. If sheer speed is a trap, we obviously need a new lens to look through to fix the potential pipeline collapse caused by all this massive code generation. We have to stop hyper-focusing on individual tools and zoom out to the bigger picture. This introduces us to a really fascinating concept, software ecology. It's defined as the holistic study of the socio-technical ecosystems that produce software. Put simply, your internal developer environment is not just a bunch of disjointed technical tools on a server. It's a complex, living ecosystem that blends your people, your technology, your incentives, and your constraints. It's all connected. You literally cannot change one node, like say dropping in hyper-fast AI coding agents, without sending shockwaves through the entire ecosystem. You just can't separate the tech from the people. To really hammer this home, let's think about Conway's Law for a second. It states that organizations build technologies that mirror their internal communication structures. Right? If you have 4 teams working on a compiler, congratulations, you're getting a 4-pass compiler. The profound takeaway here for us is that your engineering choices are ultimately a reflection of your organizational culture and values. When you bring AI into the mix, you're not just tweaking a technical workflow, you are fundamentally rewiring your socio-technical ecosystem. So let's get into section 3, the system bottleneck checklist, and finding the breaking points. Now that we're zooming out from the single developer to the whole team pipeline, we really need to evaluate what exactly is going to break when your socio-technical system scales up unexpectedly. Let's run through a concrete diagnostic checklist. As a manager, you've got to evaluate your team against the relentless strain of agentic development. Number 1, code review. If devs are pushing 10 times more code, your senior engineers are going to hit massive review fatigue. Expect them to start rubber stamping PRs just to survive the deluge. Number 2, compile time. More code means massive compute costs and grindingly slow builds. Number 3, integration testing. Suddenly, that golden rule that every single test must pass before shipping, that might become statistically impossible. Number 4, version control. Look, tools like Git are optimized for consistency, not the sheer performance stress of thousands of agentic-driven commits hitting every minute. And finally, internal APIs and token budgets. Agents are going to hammer your internal APIs relentlessly. They now need public-level security hardening, and honestly, your API token budgets could get completely drained in a single afternoon. And then there's the terrifying math of scaling. You might logically think, okay, 10x more code just means 10x more testing. But research from massive ecosystems, like over at Google, shows us that dependency graphs grow quadratically, not linearly. So a code base that's 10 times larger could realistically require 100 times more tests and compute power just to ensure you don't break anything. Ask yourself, are your server budgets actually ready for a 100x multiplier? So let's do a quick what-if drill. If your ecosystem suddenly grew by 15x over the next 18 months, what breaks first? You've got to ask the hard questions right now. Can your current release hygiene actually survive that? Can your version control handle it? What does your rollback posture look like if you're suddenly releasing way faster than you can even detect errors in production?
This perfectly sets up Section 4, Culture and Sustainable Teams, and Preparing for Amplification. Surviving this rapid transformation isn't just about duct taping broken build pipelines. It absolutely demands a sustainable culture and exceptionally strong fundamentals from senior leadership. Here is the absolutely crucial point from recent industry reports. AI amplification is a magnitude, not a direction. Think about that. AI simply takes whatever practices you currently have and turns the dial up to 11. It does not inherently fix your underlying problems. If you have great testing and collaboration, awesome. AI scales those good fundamentals. But if your codebase is a mess and your team's communication is poor, AI is going to massively amplify those bad habits, creating total chaos and confusion at 10 times the speed. This creates a wildly unique challenge for how we develop teams. On one hand, we've got these incredible tools and automation, giving us unprecedented speed and scale. But on the other hand, we have human intuition and judgment. The source material warns about a very real danger here. They call it the junior dev speedrun. You could have a junior engineer with 50 AI agents at their fingertips, essentially wielding a massive blast radius, but they don't have the 10 years of hard-earned human intuition required to manage the consequences of what they're deploying. Brute force AI simply cannot replace the essential human wisdom you need for good architecture.
So, how do we manage this? Here are 4 strategic mandates for senior leadership to maintain intellectual control over these sprawling code bases. First, you have to treat code review as mentorship, not just test grading. You have to actively teach that missing intuition to your team. Second, maintain strict token economics. You absolutely must track your capacity so these agents don't bankrupt your cloud budget. Third, enforce isolation and abstraction. Give your AI agents really well-defined boundaries and frameworks so they don't go off and make horrible architectural choices. And finally, be willing to evolve your core principles. The specific sacred practices you relied on for the last 5 years, they honestly might not survive this 10x moment.
As we wrap up this explainer, let's step into our final section, Section 5, Managing the Forest, and the socio-technical mindset. We need to take a real macro-level perspective on long-term leadership here. Historically, we're so accustomed to staring intently at each individual leaf and branch, right? We manage single pull requests, we tweak localized tools, but you can't just manage individual branches of code anymore. Leaders today have to architect and guide the entire socio-technical ecosystem. You must adopt a systems mindset. You have to step back and manage the whole forest. I want to leave you with this really provocative question. What foundational culture are you choosing to amplify? Because make no mistake, AI is going to multiply exactly what is already there in your organization. It's entirely up to you to look at your systems, your communication structures, and your technical foundations today and make sure that what you have is actually worth amplifying tomorrow. Thanks so much for joining me on this explainer, and hey, good luck out there in the forest.